So talking about natural language processing, you will find that this is another domain of machine learning where machines are doing so well. Machines are even performing in a way that human beings have never thought of. Machines are able to mimic speaking just like human beings can. And it's beginning to give a lot of problems and challenges in terms of trying to identify lies that have been spoken and versus original things. And recently, I think in China, there's been a fraud of above 24 million um, due to uh, machines being able to represent and human beings well, and somebody was forced to withdraw or transfer money from a company account, believing that he was speaking to human beings. So let's look into natural language processing, NLP. Um, this enables computers to comprehend spoken and written languages in a manner similar to human beings. And again, this is a subfield of artificial intelligence. And current common known examples to do with GPT-3 from OpenAI, which predicts the way that will come after a sentence based on ways that has come before it using artificial intelligence and statistics. Cases where natural language will be used, not to say that they are limited, but you find that NLP has been used in spam detection, machine translation, uh, virtual agents and chatbots, and social media sentiment analysis, and text summarization. Techniques that you would want to apply when you are dealing with the NLP. You would use techniques such as text removal, um, that is punctuation, removing of numbers, stop words, HTML tags. And whenever you are dealing with an NLP, I would then assume that you will understand this representation here. I have met and come across many students doing their dissertation where they are uh, trying to solve an NLP problem, and you find that they do not understand any of those items represented there. Automatically, it means to say there's no way you are going to come up with a better model when you do not understand that there are techniques that you need to apply in terms of text processing. So you will deal with the stemming, lemmatization, and post tagging and tokenization. These are keywords that you need to know, or techniques that you need to know when you're dealing with NLP. So text data is extracted from natural language, is typically noisy and then unstructured. So you would need then to pre-process the text before you can then apply it in your machine learning. And we talked about some of these being lower casing. So before you start working with your data, you would want then to more of standardize your words or the language or that your data set that you have. You'll find that when you're dealing with Python, it is case sensitive. You would want to remove punctuations and special characters, because when we are dealing with natural language processing, some of these keywords they are meaningless. They are just there for us to know in terms of the tenses that we use. And you also come across what we call stop words. Stop words are those words that we use to join words. So these words also, when we are training a machine, these words, they have got no meaning. So we really want to look into the meaning of those big words. You want also to remove things such as the URLs that are in the text. You also want to remove HTML tags in the event that you have done your web scraping. Then there's also the issue of stemming and lemmatization. These two look similar, but they are different. We'll look into them in detail. Tokenization, where we are looking into breaking bigger words or sentence into smaller words that we call token, and then text normalization. So that's a brief of what we are talking about when we're talking about lower casing. Lower casing, we're then saying that if you are looking at words such as this and a word and this, which has got a capital letter H, when you pass them through machine learning, these two are different. So when you try to count the number of words or the frequency of words, and you have words like that, they will be counted differently. So that's the reason why you would want to then put your word into one format of casing, and would prefer that you put them into lowercase. Then we have also talked about removing of punctuation and special characters. These are the words such as the commas and the periods, the exclamations, and the emojis. You would want to extract them out so that you remain with only important words. And I also talked about stop words, and to do with stop words are those words that we use to join words or sentences such as is, we, and so forth. And to help us remove them, Python has got a library that is called Natural Language Toolkit Library that you can then use to eliminate the stop words from any data set. We have also talked about removing of URLs. You would want to remove them before you start doing your machine learning. And the HTML tags, such as the boards and headings and so forth, they have to be removed, the tables from your data. And talking about stemming and lemmatization, these ones will talk in more details. And the objective is to reduce the amount of unique words. So you'll find that when you are given a paragraph, you come up with a lot of unique, a lot of words that are there. And but these words, they mean the same thing. So when we are talking about stemming there, you will find that you have words such as studies and studying. When you're dealing with stemming, these will be removed as there's remove the IES and the INGs, and you remain with study and start. So the suffixes there will be removed. But as you can look at the result there, you will discover that there is a limitation of using stemming, in that it then gives you an output which is very difficult to read. However, if you are going to look in terms of processing, stemming is light and is fast in terms of its processing as compared to its alternative, which is lemmatization. But lemmatization there, it's about grammatical information. So you have studies, and studying, it will give you start. So that's how it works. And as you can see that when you are having a sentence that has got different words like that, you end up, if you're trying to get the frequency of each word, you end up with a bigger dictionary as compared to lemmatization, after lemmatization, where it then gives you the base word of those words. But because of that ability to give you a base word, means to say lemmatization is heavy in terms of its processing. It needs more processing power. and it is slow. So you look more into details of stemming words, you see that it removes these words where you have got something like change, changing, changes, changed. It then gives you something like change. And it becomes very difficult for you to now realize what the original word was. But it is easy and fast. Um, that's about stemming. And mostly it is used where the word is unimportant, where you're doing analysis, such as where you're doing spam identification, where we are saying the word itself is not important. But when it comes to scenarios where the word is more important, you would want to use lammentization. Lammentization, therefore, it is more complex than stemming, and you would want to use it where it is more important, such as when you're doing a question and answer. So you will see that the same thing again, when you're looking into change, changing, changes, changed, and changer, it will give you the best word, which is change. Word tokenization, when we're talking about tokenization, you'll find that we are saying we have got a bigger sentence or a phrase there, and you would want them to break it into smaller ways so that you can count through the frequency of numbers. And this is the first step where when you're dealing with the stemming and lammentization. You'll find stemming and lammentization, what they will do also is that they will do word tokenization in the background. Any questions so far? Questions? Um, no questions is as good as well. I will proceed with the lecture. It's too big, right? In that level. So we have already described the Coleman techniques in NLP. So now let's look into examples of that. What do we mean when we are saying that you have to apply lowering or lower casing as a pre-processing technique? We have already explained that whenever you have got words such as we and you have got another we, which is the small letters, these words are different. So to do that, given an example such as that, right, we have got, we are about to do NLP testing, lowering, we have got capital letters there. So what we are just doing is then creating a variable that is NLP and we call lower as a method, and then we execute that. It gives us that result. So you can see that the results have been lowered in terms of the case. Then also to deal with uh, punctuations and special characters. We are going to make use of the regular expression libraries. So we import the RE, regular expression library, and we have an example here where we have got greetings, long time no see you, and we have got those emojis and special characters that has been placed inside and so forth. So for us to then do our pre-processing, we remove those special characters, and we're going to use that regular expression pattern that we pass through to a variable, and then we go regular expression dot sub, and then we put the data that way, the expression that we want to use over the data that we want, and then we execute. So we end up with greetings, long time no see you. This is a wonderful day, and it will be an amazing trip with you. So you can see that it has removed all the commas and the question marks and the emojis from that. When you continue with that, you can always just small shift. Your
Yes,
hand
sir.
is raised. Yes.
Yes, sir. You said which library do we import for regular expression library?
So we are just importing RE there. That's our regular expression.
Or RE only?
Yeah.
Okay.
Right. Then from this same line again, so here we are just going to demonstrate that you can do more of uh, uh, adding a layer of another layer in terms of pre-processing of text. So we started by removing the special characters there, and now we use the same data. We are also going to pass through um, the lowering. So you find that now we have applied, first of all, at number line 2, the execution 2, we had removal of course, special characters, and this time along we have got the lowering. When we talked about removing of stop words, and said these are the words that are most commonly written, and usually they are used to join words. These have got no meaning at all because their purpose is joining. So to do that, and I just talked about us having to um, use the natural language toolkit library there. So we just say from that nltk.corpus import stop words, so that's the one that we want to use. And then we just create our function to remove stop words, where we are saying this function, I would want to believe that you are able to do this during your introduction to programming. So we are passing in the text that we want, and we specify the language that is able to be used, because the stop words is able to be used with various different languages. And then once we have um, our stop words, we then want to create the stop words using the language, so that we set the stop words to the language that we want. And then we receive this text that we want, then we split it. So in other words, now we are creating the tokens, which is we are taking the bigger word or the paragraph or the sentence, and we are splitting it into smaller words, which is each individual word, and that is a token, more of a token. And then from there, we are now going to do the word for word in words. So we are now going to use, I believe you did the 4 in during your programming. So we are now looping through um, the words that we have created in our token dictionary. And then we are looking into those words, and we apply our stop words. That is, we now clean it up. This one is just there to print, to show you that we are doing this type of language in terms of printing, and then we'll return the result. So to do that, we are using my dog. My dog's name is Ozzy. During the holidays, we take care for hunting. So we call the method, which is this method that we have specified above, and then we specify that we are dealing with English. So let's see how it works. Now we run or pass through this data into that, so that we tokenize and we print out the tokens that have been created. So we see that it has gone through, and it has created my dog name Ozzy during holiday tech hunting. It has dropped the is and the where, and those small words which does not make sense in it. So this is how we remove stop words. And when we are talking about removing URLs, again, we will use the regular expression to do that. And again, we are creating a function using the define, and we pass through the text, and we're going to use this compile, and we use this regular expression to remove the URLs. And after that, then it has to return the results. So an example that we have there is, it says, for more details on this lecture, follow me on my YouTube channel. And we want to then analyze that data. Then we want to remove the URLs. So what we do is just call the method, which is this method above that we have defined, and we pass through the text. And it gives you that result now that it has removed the URLs. So these methods or techniques can be used one after the other, but you also want to understand which one comes first in your data. Otherwise, you end up with some ways that have been removed. And also removal of HTML tags. We can see that from this expression, we are going to use again regular expression. We have got HTML body and div and so forth that are available in this line that we have there. And now we need to use a regular expression to see the result of that line. We started by printing out the original data, which is there to see how it looked like. And this is how the original data looked like. It had all these HTML tags in it. And now let's look at after cleaning. This is how after cleaning looks like, and it has also managed to take care of the URL. Then we already talked about stemming, removing the suffixes, and lemmatization based on the grammatical information or giving us the best word. So these are just notes of everything that I've spoken about. So let's go straight into an example. And to implement that, we are going to use again the NLTK. And this time we're going to use Porter Stemma. So we initialize the Porter stemma into our stemma, and then we go into the stemming of words, and we pass through the data that we want, since this is our function there. And like I said, again, you can use the splitting to tokenize the word so that you are splitting the bigger line or sentence into smaller words, and then we now begin to look through each word and doing the stemming, and then we return the results. So we have got a word that says Peter Piper picked a peck of pickled peppers, and a peck of pickled peppers Peter Piper picked. If Peter picked the pickled peppers, and so forth and so forth and so forth. So you'll find that there are more of repetition of words, pickled, and so therefore and so forth. Let's see what happens if we apply the stemming. Okay, we not execute the first word, first cell, then we now tokenize or stem, and you'll find that it goes on to say Peter, and I say that the first stage of this stemming is to do with tokenization. So this whole sentence has been tokenized into smaller words, and just 1 minute. Sorry for that. Yes. So where were we? I had noted that I had not noted that where I had my mic still.
Unto the Lord, all I have to say is that.
Hello, Musha Musha. Sorry for that. It's an emergency that I need to attend